All right, students, lesson 1.4 is about negative exponents. We've done some work with positive exponents. Let's review that work. Here we have titles expanded form, exponential form, and evaluate. So if you look at the expanded form in this one here, you've got 3 times 3 times 3 times 3. You're basically taking 3 and multiplying it by itself 4 times. So the exponential notation for that would be 3 to the 4th power. Now if you go to your calculator and you do 3 raised to the 4th power, or if you just do 3 times 3 times 3 times 3, you'll see the value when you evaluate is 81. In this second one here, I'm giving you the exponential notation, 2 to the 4th power, which means take 2 and multiply it by itself 4 times. 2 times 2 times 2 times 2 has a value of 16. Now 2/3 raised to the 2nd power, if it's in parentheses, keep it that way. That's the same as 2/3 raised to the 2nd power. That's exponential notation. And when you're raising a fraction to a power, all you have to do is apply that power to both the top and the bottom of the fraction. So 2 squared is 4, 3 squared is 9. The value of that expression, 2/3 to the 2nd power, is 4/9. Now be careful with negatives. I'm doing this one on purpose because people keep making this mistake. -5 squared means take -5 and multiply it by itself, and I can't tell you how many kids are telling me that that is equal to -25. But a negative times a negative is a positive. Whenever you square a negative number, you get a positive result. Okay, a couple rules you need to know for tonight's lesson. First is the zero exponent rule, which tells us that any number raised to the 0 power is always equal to 1. Always. Could be x to the 0 power, that equals 1. It could be 1,000,000 to the 0 power, that equals 1. Now in this table you'll notice there's some negative exponents. We haven't talked about those yet, but here's the rule for negative exponents. If you have a number, let's call it a, and you raise it to a negative exponent, let's say a over, or negative n. In order to write that expression using a positive exponent, you'll see on your quiz next class, and a lot of times the directions will say, simplify this expression using only positive exponents. In order to write this, which is basically 1 times a to the -n, whatever is attached to the negative exponent needs to go down below. So it becomes a fraction, 1 over a. So now there's a positive exponent instead of a negative exponent. And the 1 wasn't raised. You didn't even see it there, but if there's nothing there, it's assumed that the coefficient is 1. That stays up top. It's not raised to a negative exponent. Okay? So for example, if I had 2 times a to the -n, that would be 2 in the top, and then bring that guy down to the bottom so you can make its exponent positive. So filling in this table, 3 to the 3rd is 3 times 3 times 3. That's 27. 3 squared is 3 times 3, which is 9. 3 to the 1st is just 3. 3 to the 0 power, as we just learned, is always equal to 1. So what do you think 3 to the -1 is? Well, you're just going to flip it. It's going to be 1 over 3. 3 to the -2 is 1 over 9. And 3 to the -3 is 1 over 27. So that's what we're going to practice today. Now one thing I didn't tell you, if you have a negative exponent in the numerator or the top of a fraction, you have to bring that variable or number and exponent down to the bottom to make the exponent positive. But if in fact you have a negative exponent in the bottom of the fraction, guess what? To make that exponent positive, you have to throw it up top. So let's just start with some easy ones. 5 to the 0. I know you guys know what that is. We just talked about it. Anything to the 0 power is equal to 1. Now number 2, you have a negative exponent, and I want you to write these using only positive exponents. Right now you got a negative exponent of 2, so you're going to rewrite it as a fraction, 1 over 25 squared, and 25 squared is 625. So you end up with 1 over 625. The next one, you have negative 18 to the negative 3. So again, you have to write that as 1 over negative 18, and now you can make it positive 3. And go to your calculator. If you do negative 18 in parentheses raised to the 3rd power, you end up with 1 over negative, and 18 times 18 times 18 is 5832. And that's your answer. All right, so now we have a fraction in there. Like, for example, number 2, we just had a number to a negative power, so we left a 1 in the top and put the 25 squared in the bottom. Here we have a fraction to a negative power. So when you have a numerator and a denominator, it's a little bit different, but we'll write it this way. This is going to equal negative 1, which is basically this negative here. And you're going to multiply that by, well, you got to put this guy down in the bottom to change it to a positive 4 exponent. So 1 over 3 halves to the 4th power. So now you have negative 1 over, well, 3 halves to the 4th power would be 3 times 3 times 3 times 3, which is 81 in the top. And 2 times 2 times 2 times 2, which is 16 in the bottom. Now, you can't leave it like this. You can't leave it as 1 over 81 over 16. But hopefully last year you learned how to divide by a fraction. When you divide by a fraction, you copy the first number. In this case, it's a 1. You change from division to multiplication, and then you flip the second fraction. So basically, negative 1 over 81 over 16, well, that's the same as negative 16 over 81. And that's your answer. So the next problem we're going to look at is number 5. Negative 2 over 3xy raised to the negative 1 power, which is going to become to make that a positive exponent, we're going to have to write it like this, 1 over negative 2 over 3xy. And remember what we talked about in class, when you're dividing by a fraction, that's the same as multiplying by the reciprocal of that fraction. So your final answer becomes negative 3xy over 2. In number 6 here, the negative exponent is in the bottom of the fraction. To make it a positive exponent, that guy's got to come up top. So you end up with x to the 5th power. Think of this as 4 times x to the negative 3rd times y to the 0, and look at each piece separately. 4 has a positive exponent, so it stays right where it is in the top. Y to the 0 we know is equal to 1, so that kind of disappears. But to make x to the negative 3rd positive, we would have to put him down in the bottom. You end up with 4 over x to the 3rd. And 8, w to the negative 4th is in the bottom. To make it a positive exponent, you would have to bring it up top. Okay, so we're going to now practice multiplying with exponents, only different than the class before. We're going to actually throw some negatives in there. So first you want to remember the rule for multiplying. If you have a base to a power times that same base to a power, the base stays the same and you add the exponents. So, you know, I see in number 2 there's some negatives. In number 4 there's a negative. Don't do any pulling something up to the top or bringing something down to the bottom until you've done the multiplying first. Because once you multiply, you may not have any negative exponents. Y to the 5th times y to the 3rd is y to the 5 plus 3, or y to the 8th. Not a negative exponent, so you're done. The bases are -2 here. -2 is not a coefficient, so we're not going to multiply -2 times -2. You only multiply the numbers when they're acting as coefficients. In this case, -2 is the base, so the base is going to stay the same. And we're going to add the exponents. -3 plus 6 is the same as 6 minus 3, which is 3. Since we can find a value for this, -2 times -2 times -2 is -8. Whenever you raise a negative number to an odd power, you're going to get a negative answer. 3 to the 1st times 3 to the 3rd, the base stays the same. You get 3 to the 4th. Again, you don't multiply 3 times 3 because 3's are not coefficients in this problem. They're acting as bases. In number 4, you have a like base of x, and you're going to add those exponents. 2 minus 4 is -2. To make that a positive exponent, it's got to come down below. 1 over x squared would be your final answer there. In this next one, number 1, now 2 and 3 are coefficients. The base is n, so you do multiply 2 times 3, which is 6. The base stays the same, and 5 plus -2 is 3. Positive exponent, so you're done. In number 2, -3 times 5 is -15, and -15 times 2 is -30. You've got x to the 7th times x to the 1st, which is x to the 8th, and x to the 8th times x to the -4th. Well, 8 minus 4 is 4. Positive exponent here as well, so you're done. For the next one, you're going to multiply 3 times 7, because those are coefficients. You get 21. Then you're going to do a to the -5th times a to the 0. Well, -5 plus 0, you end up with just a to the -5th. And b squared times b to the 3rd is b to the 5th. So the 21 stays up top. Your a to the 5th has to come down in the bottom because it has a negative exponent, and b to the 5th is a positive exponent. It stays up top. Now let's take care of our w's first here. 5w times -1w. Remember, that's really w to the 1st and w to the 1st. 5 times -1 is -5, and w times w is w squared. Now we'll take care of the z's. You got 2 times 8, which is 16, times, there's really a 1 in front of that, so it's 16. Z squared times z to the -5th is z to the -3rd. When you multiply that by z to the 3rd, well, -3 plus 3 is 0. You end up with z to the 0, which is just 1 anyway. So you end up with -5w squared times just 16, because 16 times 1 is 16. So you can simplify this even further by multiplying 16 times -5, and 16 times -5 is -80. You get -80 w squared. Here I'm just looking for you to fill in the blanks. The base stayed the same here, and we're multiplying. So what number did we add to 2 to make it 11? The box here would be equal to 9. The missing number is 9. Here you added some number to -4, and you got -9. So the missing number here would be -5. Oop. And in number 3, well, think about how you got 1. All right. Basically, you must have had a to the 0 power. So what must the square have been equal to? It must have been -4, because -4 plus 4 is 0, and a to the 0 would have given you the 1. Now on the bottom of the notes, we're just going to practice distributing, but doing so with variables. So at the bottom here, guys, we're just practicing distributing, but we're just distributing where the terms include variables and exponents. But to get rid of parentheses, you're going to multiply 3x squared times 2x to the third. 3 times 2 is 6. X squared times x to the third is x to the fifth. And then 3x squared times -5 gives you -15x squared. In number 2, -2x to the fifth times x squared gives you -2x to the seventh. -2x to the fifth times -3x gives you +6x to the sixth. Remember, that really has an exponent of 1. In number 3, 4 times 2 is 8. X squared times x to the first is x to the third. And y to the first times y to the -3rd is y to the -2. Now we're going to multiply by this second term. 4 times -5 is -20. We don't have any x's in the second term to multiply by the x squared, so that x squared stays the same. And y to the first times y to the fourth is y to the fifth. We only have one little piece here with a negative exponent, which has to go down below. You end up with 8x to the third over y squared minus 20x squared y to the fifth. So tomorrow in class you'll be continuing practicing working with negative exponents, and then Friday will be your first quiz.